Okay, cool. So I'm gonna start share screen, quickly introduce who we are. I'm the event host. My name is Vivian. Today I have Daniel and Lauren to join me to give a workshop on a capstone project they have delivered. They have done great work and we would love to share our work with the community. And Lauren and Daniel was a student at Data Science Academy. They just finished the Data Science Bootcamp. Especially Daniel is currently looking for a job on the East Coast. If you happen to have opening, feel free to contact him. And Lauren gonna keep going with this journey and start mastering data science program soon. Okay, so if you guys are ready to go, you can feel free to share screen with the audience. And if you're attending this event, would you mind to type quickly in the chat about what's your main interest? Are you learning this subject or you're doing work in this domain? I just want to know who is the audience quickly. Yeah, feel free to tell me your location. Like I'm in New York City. My main interest is teach and share data science in different domains. Lauren and Daniel, who would like to share screen first? Okay, I see Daniel is ready to go. Awesome.
Yep, give me one quick second here.
Okay, it's all yours. So today's event is designed as a workshop, so you can definitely learn along with the workshop. And I'm gonna share the project link with you for you to look into more details. Please check the chat. Thank you.
Cool. Can everyone hear me fine?
Yep, I can hear you great.
Thanks for going through with this entire technical difficulties and just having a bit of a late start. Happy wonderful Wednesday. My name is Daniel. This is Laurel, and today we're going to actually be presenting our capstone, which we had actually finished a couple of months back on NLP sentiment analysis. So if you don't know some of these words, don't worry. We're going to go ahead and actually describe or explain a lot of these things. But overall, we're going to basically use the natural language processing sentiment analysis to develop trading strategies in the stock market. So before we get started, I want to go ahead and actually talk a little bit about our motivation. So as you can see, like with ChatGPT and Bard from Google and Poe from Quora and all of this stuff, basically generative text and AI is actually starting to become more predominant in the space. And it's very crucial to actually understand the inner workings. And even though AI may never have feelings, people do. So in order for you to be able to actually analyze a lot of the data and trends and everything, you can do one of two things. You can either go and look through millions and millions of texts and see how people actually feel about a company or a certain product, or you can have a computer do it for you. So that's exactly what we're going to be doing and showcasing in this project today. So sentiment analysis is very significant in business for being able to do like reputation management, analyzing trends, getting a lot of the insights, and we're going to be showing you how we can actually characterize all this language into more in-depth analysis. So before we get started, I kind of wanted to talk about the goal. So the goal is being able to actually create a model and train the model so we can actually figure out how we can actually get the sentiment or the or predict how people feel about a certain stock data or a certain product or a certain thing. In order for us to actually create a model, we need to be able to have an accurate data to actually train with, right? So there is a slight issue with Twitter where you can actually just get a bunch of data, but you don't actually know if that data is correct. in terms of like how people are actually feeling. So there is this thing called stock tweets, which we actually ended up using as our user labeled data. So for those of you who are not familiar with stock tweets, it's essentially like Twitter, except with one caveat. You can go ahead and actually write what you want about a certain stock, but at the same time, you can actually label that opinion or that text with either a bullish or bearish sentiment. And because you're actually able to label it, you give the stock an idea of either how you feel about that stock at that particular moment. So we took advantage of this by being able to actually use that and input that into the model that we currently have. And then we tested it by scraping 4.7 million tweets for 19 different companies. And we compared it with scrape data that we took from Yahoo Finances. And that spanned from 2015 all the way to 2023. So in addition to all of that, we have a little bit of a bonus round, which I'll showcase later on, where we also scraped an additional 1.7 million tweets for 9 different topics, and we compared that with data from the US labor statistics. So let's talk a little bit about the pre-processing. So when you want to take certain text, text is very casual, right? Like if I'm going to be going and writing either like a paragraph on an essay, or I would actually be writing something on Twitter, it's a very casual type language, and it's very hard for you to be able to take that text and directly input it to a model. So therefore, you actually have to clean up the data a little bit. So the first part is the pre-processing step. So on the top left, you will see that there is 2 stages. You either have the CNN and LSTM or BERT, which we'll explain in a couple of slides, so you don't have to necessarily worry about that just now. But there is different ways of actually cleaning up the data. So the first part of it would be removing the punctuation, because those punctuations may not actually be crucial, and it actually would make the data way more complicated by increasing the dimensionality. Additionally, you would want to remove stop words, because those also don't provide as much context. So stop words would be things like and, I, or things like that. Then you would lemmatize the data itself. So lemmatization would be taking multiple words or variation of words and putting it to the base word. So for instance, the word study, studies, studying can actually be like lemmatized into one single word, study. But for BERT models, all of those words might actually be crucial. Having a punctuation mark, or an exclamation mark, or like a question mark might actually be very crucial to understanding the context. So we actually don't want to remove any of those. And instead, the only thing that we ended up removing would be like the URLs and the hashtags and the usernames. Also, emojis are very important. So we decided to Unicode all of them so we can pass it in through the model itself. The next step would be the EDA step. So that's the embedding step. So we wanted to go and actually see how we can like take all the words and see what importance it has based on like the words around it. So there is a word-to-vec embedding or a self-attention embedding, which we're both going to describe in a couple of slides. So I don't necessarily want to get too ahead of myself right now. But once we're able to do all of that, we want to be able to take the model and be able to represent it. So when you want to pass like all of these texts through a computer, computers don't read text, they read numbers. So you want to first tokenize and numericalize the text. So the text become vectors. So for instance, the word sentiment analysis can actually be split into 2 different vectors. So it's tokenized, and then you would numericalize it. So it actually has different numbers associated with it. So it can be like number 8 and number 16. Then you would truncate it at 31, because that would reduce the dimensionality, and you only worry about like specific words that are like the most important. For BERT models or transformer models, we do this thing called subword tokenization. So for instance, the word sentiment can actually be split into 2 different tokens, like senti and then mint, and that allows us to actually have a more accurate representation of like being able to see how much weight that attention should actually be given to like the word next to it and the word before it. So we're going to talk a little bit about that as well in a couple of slides. But there is also the attention masking, and the truncating at 64, so it can actually reduce the dimensionality as well. For the different models, we have the different hyperparameters that we went ahead and actually outputted here. And we also have the deployment phase where we went ahead and actually looked through how we can actually use this model to calculate a winning rate or create a trading strategy and see how that actually develops into the stock market itself. So the MACD and RSI is just a way for us to actually have the trend following momentum indicator. So it allows us to actually see whether something is more overbought or oversold. And the Granger causality is just a way to actually predict the correlation between two time series based on its lag. So I'll go ahead and actually pass it over to Laurel to talk about traditional neural nets.
Thanks, Daniel. I'll give you a brief overview of the different types of neural network models that we use doing this NLP task. So convolutional neural network, or CNN, is most ideal for image classification and recognition tasks for its ability to detect and capture specific features of an image with a sliding window. So we apply CNN to NLP tasks in the hope of also capturing useful features within a sentence, such as phrases or relationships between words. But beyond NLP classification, CNN would struggle and is outperformed by LSTM. And we see that even in our sentiment classification task, CNN accuracy is much lower than LSTM. But long short-term memory, or LSTM, is a type of recurrent neural network, but outperforms traditional RNN with its ability to remember long sequences, such as sentences. Traditional neural networks suffer from this short-term memory loss or vanishing gradient problem as information is passed along. But LSTM is able to overcome this by memorizing important information and forgetting irrelevant information, and ultimately passes along only the useful stuff in order to help us find patterns. And we can also combine CNN and LSTM to get the best features of each model. So for instance, the convolution layers can extract local hierarchical patterns from its input, and these patterns are then fed to an LSTM to understand dependencies related to the whole sequence. But in our case, we found that LSTM to have the best performance. I'll hand it back to Daniel to tell you the inner workings of CNN and LSTM.
Cool, thanks. So let's start over with CNN. So CNN stands for convolutional neural networks. It's known for its ability to learn hierarchies or patterns in the input vector. So it was very useful for actually seeing how the patterns are in the sentiment tweets that we extracted. Oftentimes, CNN is actually used for image classification because of its ability to actually learn patterns and see like the different stages of the patterns. We can actually use it to our benefit for sentiment analysis. So the way that CNNs work is actually through different stacked layers. So there is a convolutional layer, there's a pooling layer, and there's a fully connected layer. So all of these are just very fancy words of saying, let's go ahead and create the features, let's reduce the dimensionality, and let's extract those features to an output. So on the graph on the right over here, you can see that we actually measure 5 epochs. So an epoch is a full iteration of the training data. And we can see that around 3 epochs or so, the accuracy starts to actually diminish and actually start actually decreasing, as well as the loss start increasing. So we're like, okay, this is not too bad. It's around 0.7% of accuracy, but it actually starts to diminish. Can we do better? So the next stage was actually finding a neural network that allowed us to do better, which led us to actually look at long short-term memory. So long short-term memory is a recurrent neural network, and it's known for its ability to capture sequential long-term dependencies. So it does this through basically recursively updating its hidden states. So there is 3 gates. There is an input gate, a forget gate, and an output gate. All of these are just, again, very fancy words of saying, which information should be stored, which information should be discarded, and which information should be outputted. So it would continuously do this through its hidden states until the final like gate, and that information would actually get passed to the final, and we would actually see the results. So over here through 5 epochs again, we can see that it actually starts, it never actually like diminishes, but it actually starts to gradually level out around 4 epochs or so. At the very maximum with about 4 epochs, we got to like around 0.775 accuracy, and we're like, okay, this is kind of okay, but there's probably ways for us to actually do a little better. So before I wanted to actually talk about that model, I'm going to go ahead and pass it back over to Laurel to talk about transformers.
Thanks. Let me give you a brief intro to the different types of transformer models that we use. So after we have tried training with CNN and RNN, we thought about improving our accuracy with transfer learning from pre-trained models like transformers. So bidirectional encoder representations from transformers, or BERT, is a language model that was pre-trained with the masked language modeling objective in mind. So for instance, given the sentence, the model randomly masks 15% of the words in the input and run the entire masked sentence through the model and then predict the masked words. And this is very different from RNNs that usually see the words one after the other, or from autoregressive models like GPT, or the generative pre-trained transformer, which internally mask the future tokens. Or in other words, it only considers the left context when making predictions. But BERT allows the model to learn a bidirectional representation of the sentence. That is to say, it takes into account both the left and right context. So in this way, the model learns an inner representation of the English language that can then be used to extract features useful for downstream tasks. For example, in our case, we use a dataset of labeled stock tweets and train a sentiment classifier using the features produced by the BERT model as inputs. But there are also different flavors of BERT. For instance, a robust optimized version of BERT is called Roberta, and we can train specific tasks on. Or there's BERT trained on financial tasks called FinBERT, or BERT trained on tweets specifically called BERT tweet. And we can take advantage of these pre-trained models and fine-tune them to fit our specific needs. Next slide. Here are the accuracies that we got from these different versions of BERT. And of course, what the base BERT model was fine-tuned on is also important. So the more closely related the downstream task is to our stock tweets data set, the better. And that's why we tried a whole bunch of models that are trained on financial context or tweets, considering our stock tweets language, jargon, and sentence structure might be a bit different than the normal English text that was the data set BERT was trained on. And we can see here that if we fine-tune directly on BERT base, we got 0.8 accuracy, which is already an improvement from training on CNN or RNN. And we fine-tune with financial context BERT, we get another improvement to 0.84. And training on the robust optimized version of BERT give us better accuracy than BERT base, 0.85. And fine-tuning with BERT tweet gives us better performance than models trained on normal English text, probably from having different sentence structure or more casual language and using things like emojis. So we ultimately went with a version of Roberta, which was fine-tuned on 3.2 million stock tweets data and got 0.88 accuracy. I'll hand it back to Daniel and tell us more about the inner workings of BERT.
Thank you. So transformers in general is known for its ability to be able to actually process those long input sequences both efficiently and effectively, which is actually why we ended up choosing this as our final model, because it allows us to take all of the weaknesses that like both RNNs and CNNs have and be able to crush them. So it has this thing called a self-attention mechanism, and it does so by adding its weights to certain words. There is a query vector, a key vector, and a value vector. So the query and key vector is actually multiplied together by a dot matrix, and it's actually computed in a weight sum with the value vector to actually find its attention weight. So you can think of it like this. If you are trying to learn more about neural networks because they're very interesting, and you have a textbook that actually talks about data science in general, you can do one of two things. You can read through the entire textbook and figure out which information is like important and hopefully remember while you finish the entire textbook, or you can go to the index and find the chapter for neural networks, go to that chapter, and even then start pinpointing specifically towards transformers. And you can actually have a certain idea of like which portions or which sections are actually important and which sections are not. So in this exact context, all the different chapters that are, like not talking about neural networks would actually have an attention weight of 0, and everything in neural networks would have attention weight that is closer to 1, and specifically things that are related to transformers would be even higher, right? Like it would actually be higher than the other ones. And this is the exact type of like I guess like theory that like transformers actually have, because even though there might be some relevance based on like what was actually like talked about like a couple of sentences or paragraphs before, it might not have as much of an attention weight, and therefore it can be a little more irrelevant as the attention scores are pushed towards 0. So one thing I do want to actually point out here is that the input vectors are all processed non-sequentially. What does that mean? It means that, as Laurel said, it actually looks at the bidirectional context. So both the left and the right, all of the input vectors are actually indirectly connected to the output vectors, and therefore it's not looking at the words one at a time. So in the graph over here, you can see that there is our chart of 5 epochs, same as the other ones, but you can see something kind of interesting. We can see that like at 2 epochs, it starts increasing significantly, but so does the loss function. So that was a bit of an issue. We did not want the loss function to keep increasing, so we decided to stop it at around 5 epochs. But if we wanted to actually like see how this would actually play out and how we could actually do like what we now see as like a double dip, where you can actually have the accuracy start diminishing but increasing later on in a couple more epochs, then that would actually be represented as well in the future model. So now that we actually understand a little bit more about like transformers and our final model, I want to actually pass it over to Laurel so we can talk about how we can use all of this to devise a trading strategy.
Right. So after getting a pretty good performance from sentiment classification, we wanted to make use of this in real-world applications. So if you remember, we scraped 4.7 million tweets of 19 companies and another 1.7 million tweets for 9 other economy-related topics and classified them as either bullish or bearish. And we can use the sentiment information that we have found on the stock market to predict sell and buy signals. And we have listed here the comparison between conventional RSI trading strategies and our proposed sentiment trading strategy for your information. Let's actually head to our dashboard so you can see the results yourselves. Okay. Here's the About tab of our project. We'll come back to future work after we have introduced all the other tabs, but here is the trading strategy comparison. So conventional trading strategies to find buy-sell signals were based on 200-day moving average and RSI. So purely on price data. And the general condition to buy is when the adjusted close stock price is above its 200-day SMA, and the good strategy for buy signal is that if the 10-period RSI of the stock is below 30, which is an indication of stock being oversold, and we would buy on the next day's open. And if the 10-period RSI is above 40 or is after 10 trading days, we would sell on the next day's open. If we go to our stocks tab, you can see here, the first plot, we're showing the relationship between the 200-day moving average of sentiment and the 50-day moving average, which gives us a sense of how sentiment momentum is changing. So for instance, when the 50-day SMA crosses above the 200-day SMA or the golden cross, momentum has shifted to the upside, creating bullish sentiment, which is colored in green. And when the 50-day SMA crosses below the 200-day SMA, the death cross, it suggests lower prices, generating bearish sentiment, which is the region colored in red. And we can then use this rule of thumb as our sentiment trading strategy, and to buy at the start of broad bullish sentiment and sell at the start of broad bearish sentiment. And the next plot is the adjusted closing price, where the buy signals from both the RSI trading strategy and the sentiment trading strategy were plotted. And we can then calculate and compare the profits or winning rate for the two trading strategies. So for your information, profits is defined as sell open value minus buy open value, and the whole thing divided by buy open value. And winning rate is the number of positive profits over the total number of trades. And the results are shown here at the stats tab. And we also have a causality coefficient to characterize the relationship between sentiment and stock price. And funny enough, we have 19 companies in total, and 9 companies that we have sentiment strategy outperforms the RSI trading strategy, and 9 companies with the RSI strategy performs better, and 1 company that's tied between the two. So we can't really say which strategy is better because they're neck to neck, but we can definitely use the sentiment trading strategy as an alternative when RSI isn't performing well. And we can also click on a few different companies like Google or KO, which is Coca-Cola, Microsoft, or these are the sentiment strategy working better. But the third and fourth plot, we have momentum signals like MACD or RSI. So MACD is the moving average convergence divergence, and the RSI is the relative strength index. It's a mouthful, but they're basically saying the price momentum. But RSI is more short-term fluctuations than MACD, and we can see that if the RSI, if it's below 30, stock is oversold, and if it's above 70, the stock is overbought. And we also have stock volume, which gives us information like if the trading volume is too low, the stock might risk bankruptcy. And we also have 2 word clouds showing the most mentioned words for bullish sentiment and bearish sentiment. I'll hand it off to Daniel to tell us more about what's going on in the rest of the tabs.
Thanks, Laurel. So in addition to all of this, we wanted to give you guys the ability to be able to actually test our model yourself. So in this tab over here, which is the sentiment prediction, you will see on the very left box, there is a very casual type language. This one says, hell yeah, I'm feeling extra bullish today. Looks like them stock prices are shooting to the moon with an emoji. So we can see on the right over here that every single word is actually calculated and passed through our model to actually capture its specific sentiment. So it can either be bullish or bearish, but there is an additional weight over here. This is the composition weight. And that is the weight that is actually given to the sentence when it's actually composed together. So the weight could either be positive or negative. So for instance, if we were to go ahead and actually say like, oh no, we're about to enter a recession, sad face. We can actually classify this, and it will say like based on the models, the text is actually 84.7% bearish, and the composition weight is now in the negatives because every sentiment, regardless of it being bullish or bearish, is positive. So that over here on the bottom left, you can actually see the stats, and that is things that we actually talked about in the slides. And the sentiment topics over here is the bonus that I had actually mentioned in the beginning. So before I go ahead and actually talk about the chart, I kind of wanted to talk a little bit about the topics. So we wanted to actually look at things not necessarily related to stock. However, because the model is very finance heavy, we wanted to actually relate things specific to the economy. So the different topics that we actually ended up using would be things that are specifically that related to the economy. So taxes, loans, inflation, recession, bonds, unemployment, the US economy, interest rates, housing, etc. We scraped a total of 500,000 each for the past year. If we were able to actually meet that 500,000 criteria, then we can actually say, hey, we actually have over 500,000. Sometimes we were scraping and we never actually met the 500,000 criteria. So it actually has the amount of mentions for the past year. Over here, we can see that this is the sentiment for the past 7 days. So the sentiment can either be positive, very positive, negative, very negative, or neutral. And that is going to be completely isolated from the direction of the past 7 days, which either could rise or fall. So over here, there is going to be a chart model where I can actually go ahead and click it, and you can actually see the correlation and how it actually looks between the two charts. So on the top is going to be the sentiment of the taxes, because this is going to be the taxes model. And then on the bottom, there is a twin axis where the left axis is the GDP and the y-axis are the taxes paid to the IRS. So this is all data taken from the US government. So the data is very trustworthy. And you can actually see how all of this is very correlated, where the top is the midterm and long-term sentiment from the tweets, and the bottom is the data that we extracted from the government. And then we can actually see on the correlation how some of them are more correlated than others. So this uses the Granger causality coefficient, which is a way of us correlating two different time series together. So for instance, I can click loans and you can see how like there is definitely a bit of a dip and how that actually changes. And this one would be the consumer confidence and the bank loan rates. If I were to go down and click the US economy, you can see how that would actually correlate as well. Same with, let's say, the housing and how everything can actually increase or decrease. And this one would be the mortgage rates and the housing prices. So I'll go ahead and actually bring it back to the About tab so I can pass it back to Laurel to talk about the future work.
Right. So a quick mention of potential future work. BERT can be trained for next sentence prediction. So we can technically come up with our very own Kirkland GPT given enough computation resources. And we can also find the relationships between sentiment and stock and predict stock from sentiment. But we'll need accurate ways to represent the correlation, lag, and distance matrix between the two time series. And we can even automate this entire workflow that we have shown in this project. We cannot automatically scrape data, classify sentiment on these tweets, and alert the user when to buy and sell through email. And of course, we can always make the sentiment classification more accurate, like adding a neutral class or come up with a more accurate sentiment trading strategy. And we can add more input varieties like blogs, forums, or comments, or add more sentiment topics like Forex, crypto, and find the correlation or uncorrelation between these topics in order to diversify the investment portfolio. We also have a data tab that shows the data set that we use in our project. And we also have an About Us tab to learn more about us. But this is pretty much it of our project. You guys have any questions, feel free to ask us.
Daniel and Laura, do you think it's possible to show your GitHub? How do you construct different pieces? How do you design this project?
Yeah, absolutely. Funny enough, actually, that was it right here. So yeah, this is basically our GitHub. Let me see if I can go ahead and actually find all the different history. Yeah. So when we were working through this, the capstone project took about like a month and a half and 2 months, and we were trying to figure out like the different pieces and how we can actually get them to correlate or like connect to each other. So our goals continuously change throughout the rate, but from there we actually started in February and started actually committing through to see if we can find the best approach to getting like the sentiment and finding out like what we can scrape, what time series actually correlate, what companies actually are useful, and what companies actually like don't have enough data, and all of that. So we use Plotly Dash as our main framework, which is built on Flask. And that was the best way for us to actually showcase all of these like words and hard to learn concepts into a visual representation. So this is where we're at, and this is our repository for our main project.
What's the most difficult part for you guys to develop this project?
I think my answer might be a little different than Laurel's. I think it was like, you know, having to learn a lot of the different concepts. We were like, for me, I was knee deep into like a bunch of different research papers and trying to like understand like the theoretical instances and like how they actually like you know, like work, and like how each one is actually a little different than another. So being able to actually like take all of those you know, like theories in all these research papers, and being able to like not only put it into our model, but be able to like find a way to cleverly represent it. So that was what I thought was one of the more challenging parts. I don't know. What about you, Laurel?
I guess for me is exploring all the different transformer models. We had to learn that on our own, and it was quite the new thing. So basically we had to learn about Hugging Face. It's like Git, and you can pull different models from Hugging Face or upload your own model. And then I guess it's really hard to make the models accurately classify all the sentiment, because sometimes it doesn't perform well on the sentence that you input. Yeah, I guess just trying to make it accurate, and it takes a while.
Cool. I'm gonna open the floor for the audience to ask a question now. Feel free to unmute yourself.
Hi, I have two questions.
Yes.
One is cross-validation. Did you do some cross-validation for your model?
We did. Okay, go ahead.
Go ahead.
Did you want to go?
Is why do you choose RSI? Because there are many choices, such as Bollinger Band. So why do you choose RSI? It's a two question. Yeah.
Okay. I'll go ahead and answer the first one, and I'll let Laurel answer the second one. For the first one, yes, we did actually go through cross validation. We went ahead and actually so when we were actually going through like all the different types of models, we actually split it into three different parts. So we had the test, the train, and the validation phase. So we actually split it into three parts, and then we were actually we basically ran through the model 8 to 10 different times to actually see how each one would actually perform. So 88% was actually the final epic after we were able to actually see how all of them perform, but all of them were within like the 0.87 to 0.88 range. So this is the accuracy of a cross-validated model. But I'll go ahead and pass it over to Laurel to talk about the RSI.
Yeah, like you said, there are so many metrics of calculating profits or winning rates, and RSI is just one of the trading strategies that we went with. I guess the entire point of we did sentiment classification first, but then we wanted to tie this up and use it in real world applications. So we incorporate the classification task into a stock stock profit calculation. And then, yeah, RSI is just something that we went with, and we had to use one conventional or traditional strategy and compare that to our sentiment strategy that we came up with. Yeah, it could be anything, honestly.
Feel free to ask more questions.
If nobody asks, I will continue my questions. Yeah. So I look at you data set. So you use 1 year or 2 years data, right? How long? Because the stock market during the past 10 years pretty good. But if you use this year, stock market drops, so
Right.
you use all the tech companies, Meta, Apple, so they start drop. So it's probably
Right.
affect your result, right?
Correct. So actually that's a very good question. So what I'm going to do is I'm going to go ahead and actually bring it back to the slide deck. So what we did is we actually had a span of the stock from 2015 to 2023, because I do understand that like in 2020 the tech companies went parabolical, right? Like everything started increasing, and then starting like end of 2022, that was like the downfall of SPAC and like tech and everything. So things start like going a little the correction actually happened. So we wanted to actually get data that is not necessarily within a short-term range. We wanted to see how that actually is affected from like 2015. So that was the entire span of the entire tweets. So the topics, though, the 1.7 million topics or tweets that we actually showcased with the different like data from the government, that was only for the past year. Because that one was, we just wanted to see how that would actually correlate and whether that could actually be used for things outside of stock. However, when we were actually measuring all of this with companies and stock data, we actually went all the way to 2015.
Gotcha. Also, for the frequency, do you use like daily data or weekly or minutes data? What kind
We
of
do daily data.
daily?
Yep. So it was daily data, and then the sentiments. So what we would do is for the tweets, we would actually because you would have like multiple people tweeting about a company for like a single day. So we would actually capture the different sentiments based on like a percentage or the actual sentiment numbers, and we would calculate the average, and then that would be like the sentiment of that day. And then in order for us to be able to have an accurate representation, we made sure that the data set is a balanced data set. So therefore there isn't like more people actually bullish than bearish, and that would actually like disrupt the numbers.
And how do you determine buy and sell? You determine buy after the market, or next day
So
you start to buy and sell, or what?
So we determined the buy and sell based on so there is a traditional winning rate. So that was the moving average. So let me actually go ahead and I'm sorry, bring this back to the app that we had. So we have the conventional trading strategy, right? Which is basically the trading strategy that is the simple moving day average. So when the 30-day moving average actually passes a 200-day moving average in either the upwards or downwards direction, it could either be the death cross or like an indication to buy and sell. And then that would be the conventional trading strategy. So we took that trading strategy and used it with sentiments rather than prices. And the sentiments are the things that we actually predicted. So that allowed us to actually see how the trading strategy could actually be used, not just for prices itself, but things that we're able to like scrape and predict with the model.
Perfect. I think we still have time to take more questions.
Sure. I'll ask a more funny one. So now that you've done this project, are you gonna, how have you used this for your own investment strategy going forward? Because usually, like when we build things, people are like, have you tested it in a way that you would validate it in the real world?
So I have not had the time to do that yet, but it is on my to-do list. I think yeah, so we had actually just finished this project, and I don't know about you, Laurel, but I think at least from my end, I've just been kind of like knee deep to try to like get everything like collected and processed and everything. So I haven't really had the time yet to actually do like a full round of utilizing it for my own portfolio. But it is something that is on my to-do list.
Yeah, I think if you said like, I used this for a year and then these were my gains, and then that those results speak for themselves, I'd be like, sign me up and let me try this out. So like, that's what I would think. Testimonials get you far.
Yeah, there are
Absolutely.
actually startups using this idea, and yeah, like the entire startup surrounds this idea, so it's out there.
Yeah, great job though, guys. Thank you.
Thank you.
Yeah, if
Yeah,
you guys
I think
want to start a company with this piece of work, you're an early investor.
yeah, everything that we've written here in the future work, we are hoping to actually finish, and that is a part of our to-do list. So being able to actually automate the workflow and being able to, as you say, like learn us when to buy and sell and test it for ourselves is a part of our entire to-do list. So that's there.
We have a few people work for hedge fund and the trading firm. I can connect you with them. They can be your early adapter.
Yeah,
And
absolutely. That would be great.
they told me they pay like 5,000 subscription per month to get access to this kind of info.
Well, yeah, let's keep the conversation going.
Awesome. Okay. Anything else before we wrap up?
Oh, one more question for the tools. You use Python on premise or use some cloud skills? How do you make this window?
So
GUI?
yeah, so everything is on Plotly Dash. So Plotly Dash is on is a framework that is built on top of Flask.
I
So
see.
that was
Okay.
basically what we ended up using as our main
Okay.
framework to actually showcase the dashboard.
Gotcha. Thanks.
Yep. Cool. So if nobody has any more questions, I think we would wrap it up. I'm just gonna check the chat real quick to see if there is anybody here. Yep, looks like none of those are related questions. So thank you all for coming and joining. It was a pleasure to be able to showcase all of this to you guys, and please feel free to reach out if you have any further questions. Thank you.
Yeah, feel free to follow up us with on LinkedIn. You can find NYC Data Science Academy page. Also, as I mentioned, Daniel is looking for a position in East Coast. If you guys know any openings, feel free to contact him. Lauren is going to Australia for her next Master of Data Science. Big congratulations and best of luck.
Thank you.
Thank you so much, guys, for joining today. I hope you had fun.
Thanks, guys.